Okay, so now that we're on to number 36, we're talking about what fraction of the ice is submerged when it floats in fresh water, given the density of water at a temperature of 0 degrees is very close to that of 1,000 kilograms per cubic meter. Alright, so here's the deal. It's just the tip of the iceberg. So alright, so we have an iceberg floating in fresh water. That might be a little bit unusual, but let's just run with it. It's similar to the water cup problem we had before, where we had this glass of water with a bunch of ice floating in it. It's almost that same idea. So we have just a little bit sticking out the top. Why is that? Well, because the volume of ice is equal to, I'm picking a 1,000 kilogram block of ice just because that's easy to do, 1,000 kilograms divided by the density of ice. That's going to be the volume of ice that is contained in that 1,000 kilogram block. All right, does that make sense? Now here's the deal. The buoyant force kicks in. Something will float when it displaces its own weight in the fluid. Now our ice will displace its weight in fluid. That's 9.8 times 1,000. Now we don't have to do that because this is on Earth, so we'll just do, it's going to displace 1,000 kilograms worth of water. What's the volume of 1,000 kilograms worth of water? Well, since the volume density of water is 1,000 kilograms per cubic meter, it's going to displace 1 cubic meter of water. So our ice has a volume of 1.09, but it's going to start floating once it displaces 1 cubic meter. So how much of the ice is submerged? Well, 1 cubic meter of the 1.09 cubic meters is submerged. So we do that math and we come up with 0.917. That's the fraction. It didn't say percent, so it's not 91.7%, but that's the fraction that is submerged, 0.917. If we didn't want to go through all this hassle, like that makes sense logically, right? If we didn't want to go through all this logic problem here, the easy way to do this, and it's just always easy, it's for a piece of wood, a piece of ice, a piece of styrofoam, whatever, we can figure out how much of it is submerged by just doing a ratio of the density of the material to the density of the fluid. So the density of the ice is 917 kilograms per cubic meter. The density of the water is 1,000 kilograms per cubic meter. So we can figure out the percent. Again, 0.917 is going to be submerged. Then we can play with that. So therefore, the rest of that 1 unit is floating above. 0.083 is above the water line. We're used to percentages, so if we want to turn that into percent, we can say that this iceberg, there's 91.7% beneath the water and a mere 8.3% above the surface of the water. Hope that makes sense. See you later.